Hey guys, how's it going? So this is one of the this lesson it gives you one option for what you actually use these trig ratios for. So in this short lesson, it's the same thing we did yesterday, which was to have a right triangle and focus on one angle in particular. Like, for example, here, if I'm focused on angle A, I can make my trig ratios based on the opposite side across from A is this little a, and then your hypotenuse is always across from the right angle, so C is the hypotenuse, and then there's also this adjacent side, B. So again, you're focused on a certain angle, and then you write your trig ratios. So the sine of A is going to be opposite over hypotenuse, so A over C. And then the cosine of A is going to be adjacent over hypotenuse, so B over C. And then the tangent ratio of A is going to be the opposite side over the adjacent, so A over B. So normally we do this with numbers, not letters, and you guys saw that already. So as we scroll down here, I can kind of advise you, this isn't, the different part about today compared to yesterday is just looking up the number, the ratio, to figure out what the angle measure is. So in this first problem, you should draw the triangle the same as I have it drawn here. That way we have the exact same problem. So draw triangle ABC. There it is. And then it says let B equal 25 meters. Well, little b would be across from angle B. So across from angle B, we're going to have 25 meters. And then little a here being 21 meters, that's across from angle A. So across from angle A is where we'd call little a, and that's 21 meters. So that's all I have. This triangle is ABC. This side's 25 meters, this side's 21 meters, and it wants me to find the measure of angle A. So as you see here, so it becomes focus on angle A, and from angle A you have your opposite side over here, the 21 meters. Your hypotenuse is always across from your right angle, so 25 meters is your hypotenuse. And then your adjacent side, you don't know the length. You could get it using Pythagorean theorem, but no need. Using the two sides you know, that would guide you to the correct trig ratio, sine, cosine, or tangent. So anyhow, as you see here, we have 21 meters and 25 meters. Those are the sides I know. And then since 21 is opposite and 25 is hypotenuse, that guides me to the correct ratio, which is sine. And then, so, you use SOHCAHTOA, and it says it in a couple places here, to guide you. So again, using 21 and 25, opposite and hypotenuse, O and H go with sine. So again, it's going to be sine, so you set it up as sine A equals 21 over 25. When you divide 21 by 25, you get 0.84. And then two options. You can either use the inverse, that's why there's a -1 here, because it's an inverse function on your calculator. If you guys press inverse sine 0.84 equals, it'll tell you it's approximately 57 degrees. The other option is look this number up, 0.84, on a trig table. Let me see if I can open that up. So if you guys look this up on a trig table under the sine column, the sine of equaling 0.84. So the first column is a sine column, and you can see that right now when I scroll up, right? You have sine, cosine, and tan, and you're looking for 0.84. The closest thing, you have to either find 0.84 in the sine column or the closest thing to it. So the closest thing to 0.84 is actually this. 0.8387 is closer to 0.84 than this one. So your best answer should be 57 degrees as the measure of the angle. Again, remember you're looking up in the sine column. The second column's cosine, third column's tangent. And again, 57 degrees is the correct one, approximately. If you answer 58, it's pretty close, but 57 is definitely a bit closer. So there's that. And then if you just want to look at one more here, this next one. Draw triangle XYZ, let x equal 8 feet, z equal 6 feet, find the measure of angle z. So you draw triangle XYZ. The drawing is, it doesn't say exactly how to draw it, so just try to draw it like me, where you have your right angle at y. As long as you have your right angle at y, your triangle is pretty much going to be the same as mine. So if you, again, right angle at y, and then x and z don't really matter as much, as long as across from x you label 8 feet, and across from z, or opposite from z, you label 6 feet. So again, across from x, you should label 8 feet, and across from z, you should label 6 feet. And once again, the two sides I know guide me to the correct trig ratio based on the angle I'm focused on. So I'm focused on z, because that's the angle I'm trying to find. From angle z, opposite is over here, so you see I label it opposite. Remember, your hypotenuse is always across from your right angle. And then across from, or sorry, and then the last side would be your adjacent side. So again, from angle z, that's the one I want to be using. Stickman is there. Opposite, hypotenuse is over here, which means 8 must be your adjacent side. So on that note, using the 6 and the 8 means I have to use opposite and adjacent. Well, if I have to use opposite and adjacent, that is my tangent ratio, as you guys see here. So use tangent. Tangent equals opposite over adjacent, so 6 over 8. So there you see it. Tan z equals 6 over 8. Divide 6 divided by 8, you get 0.75. And then you can either look this up on a calculator, or you can look it up on the table. So if you guys open up the table, you go to the tan column. I could open that up one more time. Again, if you go to the tan column and find 0.75 in the tan column, that's going to be the one that gives you the correct ratio, or sorry, the correct angle measure. You already have the ratio, it's 0.75. So I'm in my tan column, and if I scroll down here, I can find it's actually 0.7536. The closest thing I can find to 0.75 in the tan column is here. And if I slide over, I can see it's 37 degrees, or at least approximately 37. So that's all you have to answer on this one. That final answer, the angle measure, 37 degrees.